Guys, our first talk is going to be from Anish Mohammed. Anish is the CTO, co-founder, and chief scientist of the Panther protocol. The Panther protocol is a privacy protocol, and I'm going to allow Anish to come on up and speak with us about privacy in DeFi with ZK. Ladies and gentlemen, please put your hands together for Anish Mohammed.
Morning, everyone. So, I only have 15 minutes, so I'll try my level best to summarize things for you, right? So, literally, I would have loved to have a show of hands of people who already are familiar with AMMs and zero-knowledge proofs. Okay, all right, good. So, I'm going to start from the very end and work backwards. So, I'll get to my slide where I have my last slide, and then go back and, given enough of time, I'll try to explain as much as I can, okay? So the first thing to say is it's like a dictum that everybody in the decentralized world should recognize. It's like for a given process, if you want to compete with a centralized system, the cost of actually just finding consensus, just consensus alone, is high enough that competing head to head might not be a great idea. That's the first thing. And second thing is like assuming all privacy enhancing technology and you were to compare them, the cost of doing that is non-trivial. So if you were to think about providing privacy, if you think a microtransaction is the place where you want to start, probably not the good place. The third thing is like in the last few years, I would probably say like 2013 was the first ZK scheme that one could implement kind of came out, Pinocchio. And like last decade has been absolutely mind-blowing. And we've had so much progress. And we've gotten to a point where a lot of things could be really done, right? So I'm very optimistic for ZK, and I'm hopeful that in near future, we could actually have far more transactions really fast at a price point where we can actually afford privacy. And the last thing I always say is like, there's no such thing as free lunch, okay? So this is what I wanted to say to you in total, and let's see how much I get through with my slides. So let me go back to my first. Okay, I don't think I'm gonna go through this, so, right. I'll take the case of automated market making. So it's like a good case to describe why you want to have some information asymmetry, and sometimes having information asymmetry has some inefficiencies. So everybody has probably seen. Oh, why is this thing not okay? So everybody has actually used a DEX. Is there anybody here who has never used a DEX? No, good. So you have seen slippage, right? So, this is a fact of life, and this is a fact that, other things happen. If you are on a DEX, sometimes you have a strategy, somebody could just front run you, right? So as somebody who is having a strategy, it might be in your best interest to prevent your strategy from being public, okay? Now, you might ask, what the hell is privacy? So this is a definition according to Wikipedia, right? I am not a lawyer. Please don't hold me responsible for this. But Wikipedia describes this as privacy is the ability of individuals or groups to seclude themselves or information about themselves and thereby express themselves selectively. The only thing I would say is like most of the so-called Western world exists in democracies, and that kind of assumes privacy. So we take for a lot of things privacy to be a default. And what is effectively happening is like we don't have such a thing in crypto in that sense. So, and this is the other thing you need to recognize. If you go to traditional finance, they do have some constructs, okay? For example, dark pool, right? Dark pool is a place where, this is a definition, but in summary, it's like, if you are a very large player, you want to move something and you don't want the market to be really affected, you want 2 transactions, that's the place you do. Unfortunately for us in crypto, it's reasonably hard to implement this. If you are really interested in the story of dark pool, actually this is the book, and there's a movie on this, and pretty interesting. And you probably should see this and then think about actually how we would probably do this in DeFi, and how, how difficult it might be to both in terms of prevent such attacks, and also like you can prevent them, but it's like the implications of such things. Like in traditional finance, when all of this happened, it took a while for them to adapt to it. So if something like this happens in the crypto space, it'll be pretty interesting. Just, just a thought. So having said this, providing privacy in a general sense is non-trivial. Okay? So this is Tarun and the rest of the guys pointing this out. Like effectively, if you were to think about a normal constant function market making and having a curve, literally what would happen is, like, if you were to try provide privacy, it becomes difficult. So they kind of said, like, it's almost hard to do this, and you can probably do, kind of three things, right? And one is like you can add some randomness to the price. Like, you have a constant function market maker, you exit a y as a constant, and at a point in time you add a delta, a random delta. You have a PRNG and add something. Second thing is like you can do batching, right? So effectively you take 10, 100, whatever n number of transactions, and you put them together. So what effectively happens is somebody who's looking for this transaction on chain doesn't see the single transaction, gets an average of the transaction. And then having said that, that typically implies one thing. You're straightening a curve. So, if you could think of this as like you're doing differentiation on an equation in that sense, right? So effectively what will happen is whenever you do batching, you straighten it out. Because you took a whole bunch of things and you take an average, so it's a straight line. But, markets are never straight in that sense. It goes up and down, and then so the value fluctuates. So there's this trade-off that happens between your cost and privacy. One, in terms of just what I described, and second in terms of, second in terms of the cost of actually providing that, right? So how do you typically provide that? And the easiest way to do that would be like use Zcash, right? Zcash easily allow you to have a bunch of transactions and put them all together. And the protocol that I have been involved in building, we kind of do the same. So this is a general principle everybody uses. Like, again, Zcash on its own doesn't give you privacy. Very important thing, a clear differentiation. If you have, I'll talk a bit. No, I'm going to skip this thing. Okay, I'll go to ZK and just walk you through. I don't think there's that much time to talk shit. So who here doesn't understand zero-knowledge proofs? Okay, good. So in summary, I'm assuming everybody understands zero-knowledge proof. Imagine I have a proof. I am the prover. Somebody is a verifier. I provide a proof that I have this ability to be in this room and get out of the room. But if I am the only person in the room, there is zero value in having a zero knowledge in that sense of my, me being inside this room. If there's only one person in this room, I am the person having the proof, you know who it is, right? So you need to have enough of membership in this group of all people in the room. So your privacy set is large. So only then you can actually have privacy. Otherwise, privacy of one is non-existent. And this doesn't come like easy. But the two things I really want everybody to think about when you think about zero knowledge is like, we typically use zero knowledge to provide, in some sense, a succinct proof for something, right? That's what we try to do. But there are other properties that we might find super useful. And in privacy sense, sometimes it's useful, sometimes it's not very useful. But I'm not going to talk about it. This talk is not about zero knowledge and how that's going to be useful in that sense. Okay, so just to give the short summary of how life in zero knowledge has happened. So as somebody who has been interested in zero knowledge for a very, very, very long time. So we've had this idea a very long time ago. Then we had interactive protocols, like getting inside the room and proving that I could actually be here or not. And then people came up with more and more smarter ways to proving this, which is like, okay, can I have like 3 interactions, 4 interactions? I mean, like not that way, but the other way around. Like you had n number of interactions, you started decreasing the number of interactions, and then you came up with the non-interactive versions. So the first of the versions that we had was snarks. So we had, first of the snark versions in 2013 or so. And then in 2017, October, Stark was born. So Snarks have some problems in the sense like, if you were to use a snark, and this is kind of interesting and important for people who implement privacy protocols and things like that. So if you are using the earlier versions of snarks that requires a setup, so say for example, if you look at set of all protocols that's available that everybody's using, Growth 16, you would have to have a setup process for every circuit you have. So this is kind of a challenge. So, if you want to have an adapter for a different thing, then you need to create a new setup. And there are universal ones like Long and other ones, which you actually do one setup and you can actually have multiple protocols being attached to it. And then, there are there are things like Stark. Full disclosure, the protocol I work on, mostly we focused on Snark, and in fact, we actually have a new Snark scheme that we came up with. Then there is the other world. Oh, I have 5 more minutes. So then there's the other world where you have Starks. The difference here is like the underlying math. So the reason I say it's interesting is like if you are working on, say, a protocol and you're on a layer 1, the underlying curves and the curves that are being supported is a key factor for you to do anything. If the curves are not supported, then you are in big boo-boo land, right? Like you can't get anything done. So when you choose your underlying primitive to do privacy, you need to be sure that the layer 1 or the layer 2, which you are going to actually do this, is supports the primitive. Ideally speaking, they should have the libraries available as well. So something useful to think about. But, it's what it is. And for the people who are interested in looking at the evolution of ZK, until 2019, there's a very, very, very good article by Eli Ben-Sasson. So Eli Ben-Sasson, he was an academic, then he got into all this ZK stuff, and he ended up being a founder for Starkware. And, it's awesome, okay? But this article is pretty interesting. It describes this as a Cambrian explosion of crypto proofs. I'm assuming everybody here is aware of evolution and Cambrian. Yeah, fine, all right, good. No, just checking. So he describes it in that sense as like we are still in the early stages of evolution. That's what he tries to say. And like if you think about it, there's one kind of a very interesting graph that's there that gives us some intuition of where we are. But my take is like, in the last 10 years, give or take, there's been significant amount of progress. So if you were to look at the cost, oh shit, you can't see anything, can you? All right, but in summary, I'll hand wave. So, and this is more Ethereum based, okay? So I've deployed my protocol on Polygon, so most of my data that I have there is from Ethereum. So effectively, what it means is like if you were to look at your cryptographic choices, you end up choosing them for multiple reasons. One of the reasons that you should recognize is the cost of actually doing the transaction. So if you have a very, very heavy primitive, effectively that means your cost of transaction for the end user becomes high. So what does it mean in terms of privacy? I mean, there are 2 choices an average person can have. You can have a protocol that actually has privacy and another protocol that doesn't have privacy. And in general, this is what typically would happen if there is no information arbitrage that exists, okay? So if there is no information arbitrage that exists, what that means is like if somebody could look inside the pool and run an arbitrage against you, then you might have a benefit of having a higher charges to pay. So let me explain what that means. Imagine a situation where there's possible MEV kind of situation, and then somebody could try friend run you. Yes, if you have a privacy protocol that prevents that person from looking into your transaction graph and what you're trying to propose, you might be willing to pay something slightly more expensive than the cheapest protocol that's available. Okay? So yeah, I mean, this is loosely speaking all I wanted to say. Like literally, that's more. Okay, apologies guys, this is a geeky thing. All I wanted to describe was like at a high level, okay? So your decision tree in deciding if you want to build privacy is kind of limited in one sense of speaking. So you can actually have like, okay, what are the mechanisms that's available to you? What is the cost for actually doing it on chain? What is the cost for adding the extra bit, what I would call the privacy set? So you have to somehow either incentivize people to be in the pool, so just as I was describing, if it's just a one person in this room, the privacy is zero, non-existent. You need to have a large enough pool to actually be able to give you a notion of privacy because of the batching would actually happen, right? So then it gives you the choice of what is it that you can literally have because of the libraries that we want to use, the throughput it has, the cost it has on the chain, right? And pretty much you would end up with like one or two choices. And going back, all I said was like, there's never such a thing as free lunch. And privacy in that sense is not going to be possible immediately for microtransactions. In instances like which I was describing where there's an arbitrage that exists and you want to prevent your alpha, shield your alpha, absolutely there will be a market for everybody to go for it. So, done. Any good questions? I don't believe I'm that good a speaker, so that's, I don't think that one.
Ben usually has a question. Ben, no questions today, brother. He's too busy. He's too busy. Sorry to put you on the spot like that, big boss. Anish, thank you very much.
Thank you.
Give him a hand. Thank you for opening the stage for us today, the Polkadot stage. Thank you.